จารย์คะ
ครับครับ Do you have question?
Yeah, for the in-class exercise for the previous one, um, the when you say like, for example, find a file or something, do we declare the file in the beginning or do we need a user input?
You mean, can you clarify what do you mean by using the input, I guess?
I mean like for most of them, like
Uh-huh.
the first, like, wait, let me open. It says like check if a file exists.
Yeah.
So like, do we need a user input to know what kind of file you're looking for, or do we just declare a random file in the beginning?
So if the particular I guess items in the in class exercise is like, okay, can you find certain files that you want to search? I just want to make sure you know how to use the command find, which is basically find file name and some target location, right? So you can pick whatever target file you want to find and just put in the command you put in on the worksheet.
Okay.
Yeah.
And
Basically, the goal is to make sure you at least for once type in the command and see what output do you get. If the file you are searching exists somewhere in the directory that you're searching, you should be able to see where it is.
and do we write down, you only submit the task, right? Not the preparation.
Yes. Yes, just the task that just the command that you do to actually finding the files for that particular instance. Uh,
Okay.
no need to kind of like wrap up or write in like the rest of it.
And all the shell commands, do we write in one file or we separate in many files?
Either way works. For the shell command, to be honest, if it's a script, I would appreciate if it's everything in one file.
Okay.
It's a lot. So from like the grading perspective, that's a lot easier to grade. Uh, and go through your command.
And also, last question.
Mhm.
Wait, I was thinking of something. Wait, forgot. Oh yeah, the file name, like, is it .sh or .bash? When I search it up, there are two of them.
So a more common one, both would work. Basically, as I said earlier in the, I think first week of, first lecture or the second lecture, the extension like .sh, .bash, or .something, to be honest, that doesn't really matter. The reason why that doesn't really matter is at the end of the day, you use shebang at the top of your file to say, use that particular interpreter on whatever comes next.
อาจา
Okay.
รย์ the square เครื่องหมายตกใจบิน /bash ติงอันนั้น
Huh?
อาจารย์
The shebang, yes, the pound exclamation mark ไอเครื่องหมายกล่องแล้วก็เครื่องหมายตกใจอะครับ
Thank you very much.
อันเนี้ย
Basically the .sh or .bash, most of the time we put it in there so that if your friends look at your folder, your directory, they can know that okay, that's a shell script, that's a bash script, that's a Java language, that's a C code, that's the executable, for example, or that's the image, and uh, many program would take certain extension. So some program has limitation on what's the extension that they would take. For example, if you use the video player, it would tell, okay, are we opening the MP4 files, the WMV files, like all those video files, right? Uh, So that's what they are for. And the more common extension for a shell script would be .sh, but .bash is also okay. .sh is a lot more common, as long as you have the /bin/bash, then you make sure the execution mask for the ownership is one, right? Then you can run the file.
Okay, thank you.
Yeah. Do we have class on Monday? Yes, we do have class on Monday. We will actually for the Monday and Wednesday class, if there's no rescheduling, there will be it should be one link, one password, which I will send out uh, definitely before class on next Monday, and then we'll keep using that link unless we have to reschedule. When we reschedule the class, I think WebEx still not allowing me to use the same link. I will try to figure it out if we can use the same link. Hopefully, there will be only one or two more meeting links that you need to use to join our class, and then most the rest will be a static. Join, go through this link, the same password, and then you should be able to get in. All right, so let's begin the class today. I know the schedule said from bits to C and from bits to program, from program to bits and introduction to C. I want to push that to Monday because not every one of you are in this session. And that is a, to be honest, if it's something you get out of this class is those content. Basically what I'm trying to get across would be when you write a program, how does the machine take your program and run it in a high level, in a more general level understanding of, okay, this is what happened when I run a program. And then we'll dive into, okay, how do we write a C program? Today we're going to switch gear a little bit and talk about version control. So because it's a switch gear, let's actually do this mental exercise. Imagine you're working on a group project, and then imagine you spend the last 7 days cramming your code in. Then you finally think that you have everything working, and you're planning to do one pilot run to see everything works or not. You create a directory to store the results, you make some typo, and you type in this by accident. Hit enter. And because you've been working on this for 7 days, you hit enter without thinking. What do you do? If that's me, I would kind of cry in the corner and get depressed and then kind of need to come back and rush through your code, writing the whole thing again, right? That's not good. Let's imagine another scenario. Same thing, right? We have a group project. You spend the last 7 days cramming the code in. It's not working yet. There's one bug that you're trying to get rid of. Something is wrong with your code, but it's only one small thing. You make one change to get rid of that bug, but that change introduced 3 more bugs. You try to get rid of those 3 bugs, create 10 more bugs while debugging the old one. Right? This can happen in a large project where you have hundreds of files, hundreds of functions that interleave, interact with each other. Sometimes you fix one function, it generates a bug on the other function. And then what happens is you then sit silently in the corner, wishing that you can revert back to the version where it's only one bug. Or at least, right, can I compare the 2 versions somehow? Right now, you only have one version of your code. Again, sit in the corner and get depressed, right? Have you ever run into any of these scenarios at all, right? And for me personally, the third one hit close to home. There are many instances where my computer crashed while I'm writing something in, say, Microsoft Word. And back in the day, these say if Microsoft Word crashed and you boot it up again, it would try to recover the latest version. And even though it's not the latest, but it's still something, right? Back in like 10 or 15 years ago, when I was still younger than this, I type in something in Microsoft Word, computer crash, it's gone. There's no backup, there's no temporarily store Word document. Or your friend accidentally delete my code. Uh, the first two is kind of like this can happen as well. I swear my code worked yesterday. We call this something like advisor syndrome. If you go to like for example the PhD comics, there's a few strips, comic strips that say, okay, everything would work in the lab until your advisor pass by and look at what you're doing, and then everything break down. It happens. All right. So at first, again, basically, you can run into this scenario. And what we are going to learn today is a remedy against some of these scenario. How many of you heard about version control? What does this word mean? All right. So what is the most primitive form of version control? Let's say you don't know how to use Git, you don't know how to use Subversion. What do you do to back up your code? What do you do to back up your data? Saving, right? Saving will back up a copy of your data, but it overwrites the old version. So what if I want to keep both versions? Right? If I want to keep both versions, one thing I can do is do this. Right? Basically, I do cp-rf, create two different directory, one with the old version, the other one which would be the new version, and you can keep editing the new version. This is part of it. We call this archiving. Archiving is we keep storing data while we are moving on, right? It's the same as how human archive knowledge in the library, for example. They put books in, they put documents in, so that you can come back and look at those documents later. So this is a manual thing. You can actually do this, right? And this is convenient to some extent, but it's also inconvenient in certain other extent. Why? How can you tell that, hey, what are the changes from folder one or the copy of folder one from 5 days ago? Who have made those changes, right? So computer scientists come up with this thing called version control system, which is basically a piece of software that would track all the changes that you have made from point A to point B. The benefit is if you know the changes, it allows you to go back in time. You can start from where you are, the current version of the code, and you're like, hey, I don't like this version of the code. Somehow, the more I debug, I somehow add 5 more bugs. Every time I try to debug one simple thing. So I would revert back and take my knowledge that's in my brain about how this bug behaves, and then redo the whole thing again. And hopefully this time I got rid of everything, all the bugs, not the code, obviously, got rid of all the bugs, right? Uh, Another thing that version control system is it allows you to track people's individual contributions to the changes, right? So you can see who did what. Basically, if it's a group project, I can see I ask like someone who grade your project and see who is contributing to what files, right? If someone's working together, I can see who did it. who make the change on what line of code and how. This allows you to see who created that bug that I've been seeing, so that I can talk to that person on why do you put that line in, because all like in all cases, right? The reason you put code in is you want to either add functionality, make performance better, or get rid of bugs. There has to be certain reason that person add that line of code into your project. So you can talk to them. You know who to talk to. You know why they add that line, and we can basically, you and that person can come up with an idea to reach the same goal without bugs, right? So generally, these are really, really useful tools when you graduate from MUIC and actually go out work on at a company. This is something that every single tech company is using. So you better get familiar with it. It is not hard at all, right? And these are some of the tools that are popular. I talk about Subversion, right? Subversion is the earlier version control system that's still being used nowadays. Mercurial, I've seen these being used, for example, when I was an intern at NVIDIA Research. They use Mercurial to kind of store everything. So a lot of tech companies still using these software. Git is popular amongst individual developers. The emergence of GitHub and Bitbucket, which is a public server that you can store your code in and do the version control, helps making Git really getting popular. Because first of all, it's free. You don't even need your own hard drive for this. You can store it on the server, and people can contribute to your project. There's an interface that people can come in and comment on your code, and then you can take the comment and resolve it, right? So it has a lot of built-in that allow collaborative development, which is a good thing, especially now that we are in this COVID pandemic, right? We all have to get stuck at home. We can't go anywhere, which means that these tools would become even more powerful. It allows you and your friends to work on the same piece of code at the same time. Now we'll talk about that. This comes the concept of distributed version control system. When we put the word distributed in computer science, most of the time it means that some machine would perform certain tasks, some other machines would perform a different task that are involved in the same project. Right? Distributed systems mean that a big computing system where you run a program and the program would be running on multiple machines. Each machine would finish certain tasks. Over here, distributed version control systems basically means that you can have a local copy of the code on your laptop, right? On your laptop. And there can be multiple copies of the code on your laptop, on your friend's laptop, on the server, on your teacher laptop, right? Everyone can see some version of the code. And there's no need to always talk to the central server when you modify the file. You only have to synchronize basically once you hit save, you can write in the command to say, okay, push all the changes you made locally on your machine, right, into the server. So let's say basically you have this central storage. This is where everyone see the most updated version of the code, right? And this is local. This is your own desktop or laptop, right? And you perform some development. So right now, let's say this is version 1. You develop it, make it version 2. Your friends also develop it, make it version 2.1, right? It's a two it's a different version that's on from version 1, then you can say, okay, I'm going to push my change here, overwrite version 1, and it becomes version 2. Your friends can come in, okay, I'm going to merge my change that is on the same code, make it version 2.1. And then from this central system, right, what it would see is it would see this version 1 that get evolved into version 2 that get evolved into version 2.1. You can always revert back in time or go forward in time to change into a different version. Now you can probably see the benefit of having these version control systems where you can always have a choice to go back in time, go forward in time, branch the code into very multiple different versions. You work on certain functions, your friends work on a different files that are tackling different functionality of your program. This way you can have multiple people working on the same project. One would be, okay, let me handle the code that deals with the matrix multiply in here in this fraction of the machine learning pipeline, for example. And then your friends can work into how do I take the input image and then convert that to something that your machine learning system can understand. It's a two different piece of code of one big program that want to say image detection, right? So a good and popular VCS or distributed VCS would allow you to actually collaborate on the code and work independently. And one of the major tools that people use these days are Git. How many of you use Git before? Just out of curiosity, I just want to see, do you like it or you hate it?
I like it.
Okay. All right. Awesome. One of you said you used it before and you like it. Another your friend said, okay, you use it a little bit. So you would love it more and more actually once your code gets bigger and bigger and bigger and there are more people in the team to work on your code. The reason behind it is because it allows a lot of people to work on the code in parallel. And still, you can still yell at your friends through Git interface like, what did you do over there? I don't understand. Can you please merge your version with my version? Things like that is allowed in Git. But don't physically threaten your friends, right? At the end of the day, this is one of the most popular distributed VCS, which has the benefit of easy branching, easy merging. We'll talk about what do I mean by branching and merging. It allows a really flexible workflow. You can go back in time, you can go forward in time, you can contact your friends, you can actually put in your own message whenever you want to modify any part of the code and we call it commit, which is push all the changes you make into the public, into the global version. You can say, okay, this is what I do. It has data integrity, which is another important aspect on the back end. Right? So you might have heard about the word back end versus front end. I still personally hate the word back end because it actually means multiple things. People from the software engineering and front end who work on like the interface and other software that interact with the user love to call people like us backend. And I'm like, there are so many things into that backend. There are compiler, there are the OS, there are the scheduler, there are the runtime, there are the actual optimization for the hardware. Please be specific so I know what you want. Data integrity is something that allows you or the server to check if your committed change is corrupt or not. Because when you deal with a networking system, basically in the distributed system, when you send data packet over, your data is literally being transferred in the air or through the Ethernet cable, right? When you have the data transferred through the Ethernet cable or somehow on the air around you, one thing that can happen is bit can flip, right? From 0, it gets flipped to 1. Think about it this way. These things are either electrons or some form of energy that follow the physics rule of physics, right? To get from one place to another, which means that they are open to any outside factor. There are things like random gamma particles in the air from the sun, right? That can hit that electron and bounce the electron out. So the data gets flipped from 1 down to 0 because I don't have that electron anymore. It actually happened. If you've seen a blue screen that says memory corruption, this is probably one of the cause that can happen in your computer. That's actually a few parts that emit this gamma particle that can randomly hit your main memory, the DRAM that when you buy it, right, it contains electrons. Those gamma particles actually hit those electrons and bump the electron out. The bit flip from 1 to 0. Your machine are like, wait, this value make no sense. I'm gonna go into the blue screen, reboot myself, and you as a user like, what the heck is going on? This thing can happen. Data integrity allows the system to check if the data is correct or not. There are depths of research going into how to check it. If you're curious, feel free to let me know. There are actually mathematical equations that you can use to check these data integrity. Another thing is high performance. You want to make sure that when you commit your code and see the code changes, those are available as soon as possible, and a lot of people can use it. GitHub, for example, is hosting probably millions and millions of people's code right now, and somehow they still manage it without you feeling like this resource is shared by millions of people, right? So this is actually delivering pretty high performance. So this is also the benefit of knowing the system, computer systems, right? It allows you to make a computer and program behaving as if you are the only one, the only user. No one else is using it, but in fact, you actually share the resource with many people. Okay, so you might have heard about this another word that if you use Git, right, we would refer to repository or repo, right? This repo really means that it's a collection of files or folder that we want to do version control. It's a folder that you want to archive. The history that I said, version 1, version 2, version 2.1, version 3, version 3.1, version 3.2, these history are it would appear in a snapshot. The analogy I would make, and hopefully this ties back to everyday life, right? If you play games and you play around and then you need to fight a boss in a game, right? What do you usually do? At least for me, what I would do is I would go and save my game. Just in case I go and fight the boss and I got killed, right? So that I can load the game, go fight the boss again, and hopefully this time I know exactly what to do. This is almost the same as version control. When you save the game, you save a version of your environment, right? Your file, the folder, and everything. When you need to debug your code, think of it as you're fighting a boss. And then the bug kills you. Like, okay, fine. This way is not working. I load the game again, go back to the older version, and then go fight the boss again, but with a different method. So hopefully this time you progress. This process is called commit. Committing the code means that I'm gonna save the game, basically. Save whatever you have in the current version right now. Take a snapshot so so that you can always come back and start from that point. And a repository can have different branches, right? Each with their own history of development. If I go back to the gaming analogy, This is something like when you save the game and you go into one part of the story, and then you go back and load the game, and then you now branch out into a different storyline of your game. Any questions before we move on how version control and how does snapshot work? All right, if you have any lingering questions, feel free to type it in. As I said earlier, this video is actually recorded. It will be posted on the YouTube playlist that I share earlier this week. And I'll post this one right after WebEx process the video, and then right after YouTube finish processing and also encoding the video. All right. Now let's go to visualize what does it mean to have different versions. Right? As I said earlier, you have multiple files on the repository. If you work on a big program, there have to be multiple files. There can also be multiple versions, right? So let's say from version 1, this is the initialization. This is where everything begins. This is where you start version control. Someone make change to file A and file C and say, okay, I make enough changes. I think there's no bug, but we have new functionality that is awesome, and I want to push it so that everyone can see this new version. I commit. Right? So you commit the change. Here, take a snapshot saying, okay, this is the difference between version 1 and version 2. What are the differences? File A and file C. Then someone comes in and say, okay, I can improve file C even further. So you commit again, you make some changes and commit into version 3. Now the new files, the new version of file C would be taken a snapshot of. And then let's say your friends come in and now realize that, okay, no one modified file B for a long time, and there are things he can do to make it better. So he comes in, change file B and file C into different version of his own, right? You commit again, and now you are at version 4, and then now you are at version 5 when another person comes in and change the code. Basically, this allows you to keep all the version, keep all the changes. You can go back in time and see each individual version. You can even go back in time to see individual version of certain files. It would actually record for file A, there are 2 changes. If you want to go to the first change, go back to version 2. If you want to see the second change, go back to version 4. If you want to go back all the way, go to version 1. The same thing goes to file B, but it would tell you, okay, you can go back to version 4 or version 5 for different version of the file. So now that hopefully you're convinced that, okay, this is useful. To create a new repository, this is the command you put in, git init. These basically initialize a new repository by create a hidden directory in that folder that name .git. So let's say you are in this folder that is your repo, right? There'll be this folder called .git. These store all the data for version control. Things like changes between different versions, what are the branches, who are the user and who have been committing code, what are their email. Things like this will be stored in the .git folder. Then if someone already create a repository that hosts certain program and you want to clone it, you can run git clone with the repository name. This basically clone the remote repository into your local location. And I'll I'll have a high level explanation in here. Basically, what happened is this is your basically your machine, say your laptop, right? And this is hosted on a server or the master repo. So we would call this a master, which is the global version that everyone would see. This store the last commit, the most updated version of your repository. This store your own version. When you add things into your working directory, think of it as a sandbox. You keep adding things, but you have not committed yet. When you actually call commit, these changes will be snapshot and saved into a state. It's a state in your version control system, but we call it the index. It creates a version before you push it into the global world before your friends can see it. So this is still local and this is global. Okay. And the difference between here is this is not committed. So no version whatsoever. It's your code that you're developing. That so for this you have a snapshot. You can go back in time, go forward in time once you commit. Any questions about the difference between the head, the index, and the working directory? Basically, the head is where every information is stored. Index means that it's a snapshot that you're working on right now that you save. The working directory is where you are right now. Where you are and developing the code, you haven't really saved any changes yet. You haven't take a snapshot. All right. So if you want to, for example, we call this stage a change, which means that you want to add some files, modify the content of the files, or these kind of thing, right? So let's say originally you have file A. This is what originally exists. This version 1. It's version 1 of files A, right? File A. Then this file A, because it in the master, in the head, right, it also exists in the committed version. And then you have this working directory. You have the same file A, but it's a version 2. You want to add this into the repository. What you can do is to call in the command git add and then the location of the file. What it does is it would actually push this version 2 into the index, right? Into the index to replace version 1. Now the new file is snapshot. It's being version. It will have a version number that you can always go back to this version. You can still again go back to version 1. Now you have both version 1 and version 2. To actually push this commit to the head, right? Push the commit to the head, you can actually type in the command git commit. This get pushed all the way to the head. Basically, the version 2 which stage in the index, which is where you are right now, the current version that you're working on, it would then be pushed all the way to the head, which is the most updated version of your repository. If you say, hey, hold on, file version 2 has a bug, and I don't want to publicly expose version 2, I'm going to revert it back to version 1. This is what you can do. Git reset and the file name. These allow you to, now, let's say you push this, you do git add, right? To the git would put version 2 from the sandbox to index. And you realize there's a bug. So let me go back to version 1. You can do git reset on the file name. What happened is file A version 1, which is at the head, get back here, replace version 2. This is when you go fight the boss and you get bin. And then you realize you need to load that old version again. You do git reset. The version 1 would now replace version 2 in your index so that you can start again from version 1. If you want to make sure that file is all the way back to your working directory, you need to add this additional option --hard, which means that you are doing a hard reset. Give me version 1. I don't need any trace of version 2 left. It's so messy and buggy that I don't need that file anymore. Give me version 1. This is what you can do. And then, because there are multiple versions, one thing that would happen now is you will get confused about, okay, what's my version? What are the branches? Are there new files that I haven't staged the changes yet? Are there modifications to the file that I need to push? You can type in the command git status. When you type in git status, your current repository will print the status that they record in the .git folder and show it to you. For example, this tells you that these are the changes that you have to git add, right? Git add that haven't been pushed to the head, pushed to the leftmost of the staging area, that you still need to run git commit so that everyone else can see the change. These are the files that you modify in your working space that you have not even added yet. It's not staged for the commit at all, right? So you need to use git add. It would basically tell you this is what you need to do if you want to make sure everyone can eventually see the changes. Perform git add to the file. These are random files that haven't been added. It's a new file. It's not tracked at all, right? It would tell you, okay, this is some random file you add in. Do you want me to add that? Do you want me to just leave it alone? If you don't do anything, Git will leave that alone. No one can see this file. All right. So any questions about staging, reset, and kind of revert back and forth in time using git add, git commit, and git reset? One thing you can do is a command called checkout. Checkout is almost the same as reset. Basically, you check out the most updated version of the files, discard all the changes in your working directory. All right, so let me go to the next concept, which is called branching. Branching essentially allows you to develop the code across different versions. So let's say this is the master. This is the most updated version that is where the head is, right? Is where everyone sees. Then your friends come in. I want to add some random features from this version into this new features. They can create a branch. Let's call this branch 1. Branch 1, right? And then you come in and say, okay, I want to start from here because that's the version you see. And then I want to add a lot of features. This is branch 2. This allows the whole repository to maintain different versions and different branches of your code for each features where you can merge it later. This allows your friends and you to work on 2 separate pieces of code, and hopefully at the end of the day, you merge back into this common version for everyone. To switch between branches, you can use the command git checkout, right? So let's say you are at the head and you're at the master branch. Master branch is the main branch. Basically, when you see master, it means that this is the main branch that everyone sees. It's the main and the global branch. When you call git checkout master, your code will be the same version as the main branch, the most updated version of that branch. You can do check, I think you can basically check out branch one that I said earlier. So friends in want to develop my own version, I branch it out calling it branch one. So you can do git checkout branch one. This allows you to switch your version to branch one. Your code on whatever you see on the folder will be corresponding to branch one's code. Master is still there. You can also switch back to master. Right? You can even create a new branch. Let's say you have these two branches, master and branch one, and they'll say, okay, I want to develop my own version of this function. I want to create branch two. What you can do is git checkout with the -p. -p means that I want to create a new branch, and you put in the branch name. It allows you to actually create branch two as another branch of your Git repository. So when you call in checkout, this is what happened. When you do git checkout branch one, right? It changed from this version to a code in this version. So this is after checkout, which allow you to see a different version of the code that get branched earlier. You can switch back, switch force between branch one, master, branch two, and any of the branch inside the repository. Now, we've been talking about distributed VCS and working with a server such as GitHub, right? This is what happened. We have a remote location. Let's say this on GitHub. And your local location, which is on your desktop or laptop, right? So one thing you can have is you can have the master branch on the remote location somewhere that hosts the version that everyone sees. You can take the code from that version, then develop more features onto it, such as the new version on the master on your local location. Then you branch out into two different branches because you want to work on two different features. At the end of the day, you can update, right? So once you have this, you can update this by calling push and pull. So first command that I'll talk about is not updating, but how do I get the most updated version on the remote location into my own local location. So here is the command git pull. When I type in git pull, whatever is the most updated here on this branch that you are in will be downloaded in some sense, right? It will be downloaded to your machine and update everything. Here's an overview. Let's say you have in your local machine, this is your machine, right? And then this is someone else comment, right? And you want to get from here to here. When you do git pull, basically it make you get from here to here. Basically switch to another version that is more updated in the remote location. To push your changes that you commit to the remote location to the server, you can do git push. Basically, git push means that you have this updated changes. You push it to the server so that everyone can download your change. When you do this, this is what happened. This is where you are. This is where the server is. When you do push, you basically push this into here. So origin master, which is the server side, will be on the same point of where you are. Here is the workflow summary. So if anything, if you're confused about how do I deal with this is your own uncommit changes. This is stage changes. This is commit. And this is on the server. This is a quick cheat sheet that consists of all the commands to get from one version to another. You can get from the workspace to staging by using git add. You can then use git commit to get this fast forward all the way to a local repository, right? By using git commit -a. Git commit -a is one of the probably most common command you're going to type when you deal with Git. So this is, I'll put asterisk in here. This is one of the most common. This is another common one. You make some changes, you're like, oh crap, there's a bug in here. So git reset and the commit version get you back to the version you want. Git push is another common one that you would need to use. Push your changes to the remote directory. Git clone or pull is another common one. So these are the 4 most common commands that you are going to have to work on that is illustrated on this cheat sheet, right? So the question is, what if you and your friend develop code together at the same time, but on the same function? What do? It means that there are conflicts, right? You make some edits, your friend makes other edits. There are some conflicting opinions on how do you want to deal with the function. This is what you have to do. Basically, who commit first would not have to deal with any other changes, and who commit second would have to perform the merge. When you perform the merge, this is what happened. You can have the merge in a fast forward option. This is version 1, this is version 2, and then your friends want to push in, okay, this is version 2 and this is version 3, right? This is you, which you commit first, and this is your friend. And commit. What your friends have to do is, okay, I would fast forward the version of the master so that everything points to my current version. This is called fast forward. There's no branching involved. You can merge 3-way in a sense that this is the changes, right, that someone else make to the master. This is version 2 and this is version 3. And now someone changed the code again. This becomes version 4. Version 4 stem from version 1. So the change is something like this. There is someone working on version 1 to version 4, and then someone else has version 1 to version 2, and then your friend make another change to version 3. What you need to do is call merging 3-way, which is basically merge version 3 and version 4 into version 5. Okay, so this is version 5, the merge should be a little bit more involved in the sense that there are more files that are different. So you need to be a little bit more careful. By more careful means that in most cases, someone need to stare at the screen to figure out for these files and this function, which version is the correct one? How do I merge them together? It takes time. There are actually engineers that most of the job is to figure out how to merge the code from multiple people. And it can be depressing, but it's important to make sure your program runs correctly. And here are the summary of the command that I'll put together, right? So treat this as a cheat sheet that you can take and when you need to deal with Git repo, these are the common ones. As I said, the common ones are this three, right? And then the Git checkout is another common one. So checkout and reset is something similar, but checkout you can actually get the specific version. You can go to the actual version of the file you want. And that's it for the class. I will show you some example of the repository that I have on GitHub, and I'll show you what do I mean by different version. So give me some 1 minute to log into my own GitHub folder. All right, so can you see my screen now that I'm sharing with the website? So this is what you see when you use GitHub. It would show the structure right over here, the structure of your repository. These are the folder that are in the repo. Inside each folder, you can actually click in and you will see what's inside. What are the files inside there? What are the different pieces of code? So you can go to source, for example. This is where I store all my code. You can see that's .cc, which is a C++ file, .h, which is a header file. We will talk about this in a little bit more detail once we go into C. And you can see here, you can check out the most version, the comment that I put in for the most version. And what I said is like, okay, I make some changes and I believe this is much easier to use now. This apply to any files involved with that version. If you click on certain files, so I'll load up the file that gets changed really often. For example, you can see that from GitHub, I can see the source code, right? What goes in here and what did I change. So you want to see the change, you can go all the way up here and click on history. The history would show all the version that everyone tried to change, right? And you can see the comments associated with each version. You can, if you click on each of these comments, you can see the change, right? So I remove this line and then I add these 2 lines to basically debug my code. You can also see the version number here. So when you do checkout, you can put in this exact number. It would revert your program, your code to this particular snapshot. If you click on the version number, you can see all the changes on these files. It will say, okay, this file has these changes. And you can even write additional comments at the bottom. So that's why I said GitHub is popular, because of how good the interface is. You can go through the files, You can comment on certain versions. You can even blame. So don't do this often, but it's possible. You can blame, right? And trying to figure out what is wrong with the code. You have the path, right? The path similar to Linux on the whole folder structure. These are the file inside the folder called gpgpusim, inside the folder called source, inside the folder called 3.x, version 3.x. If you click on here, it's like you do cd change directory to this folder. You can have issues that people can put in, right? So you can open an issue if you host like some code. You can host you can actually discuss among your colleagues. These are the issues that we need to resolve. Then if you go back all the way, you can see this is a private, right? So private means that you can share to specific people that have certain account. This is free. So you can actually have a private repository that no one can see what you're doing, but you can still keep the version control. Or you can make it public where everyone in the world can see your contribution, right? So they can download the program, they can use the program. When you want to, let's say, clone the repository, you can click on clone or download. Copy this, do git clone, and followed by this URL. It would basically copy everything that I host over here on your local machine. It even support a README file. So if you have a README file, it would get print out down here on how to use it. And it would also have a branch that you can track. So over here in my infrastructure here, I have 3 branches, right? And then if you look at another thing that I want to show, which is comments. So these are all the comments that everyone who developed this code has pushed in. There are right now 2,000 commits, and to be honest, there's a lot of commits that are really, really small. I make one line changes and I commit because I want to make sure that all the changes are there. So that's basically that's the overview of how you can use GitHub to save your code, right? It is really useful. You can even see the contributor who has been changing the code, right? It would show you the username, I believe. And okay, take some time. So we are going to go back. Any questions about how to use Git or GitHub? Because on assignment 1, I would put that as a part of your exercise in assignment 1, which is basically for things that you develop. Put it on GitHub. Make it private so that no one can see it, but make sure I can see your code, and it allows you to practice some exercise on how to use Git. This is one single tool that I can guarantee if you work on anything computer related, you would need to use it. All right. It's not exactly related to the content of this class, but it's one of the material that we want to make sure you at least get some practice. Right? At least get some practice. There's a really, really small chance that any questions about Git will be on the exam, but I assure you assignment 1 will ask you to deal with Git. Okay? I want to make sure you get some practice. Assignment 1 will be out tonight. You on all the assignment, you have 2 weeks to work on it. For this assignment, because it's out on Friday, I would give you 2 weeks and 3 more days. It will be due Monday the following week. The following 2 weeks, basically, you have 17 days to work on assignment 1. And to be honest, assignment 1 is relatively easy if you do the in-class exercise so far. It involves shell scripting and a little bit more involved on, okay, what do I write to get the exact thing that I want? How do I deal with Git? How do I create a repo? How do I actually work with Git? And once this is over, assignment 2, 3, and 4, you would then notice some ramp up in the sense of you go into C code, right? It will be more along the line of the materials that we talk about in class. Assignment 5, it would likely be more like a written assignment. So we go into a little bit more of a theory into how computer works. So there might be a little bit of a homework styles rather than a lab. Next week, as I said, we'll start to go into C, which is the gateway into working with computer systems. Don't, I know that some of you might feel like, okay, it's going to be hard getting from here on out. Don't be. Everything is not as hard as maybe your upperclassmen telling you on like, okay, I don't want to deal with C anymore. It's annoying. It can get annoying, but if you have any questions, you can feel free to ask me. I would get back to you as soon as possible, as usual. So please don't feel scared even before we go into this. And if we go into this and you're like, okay, I'm utterly confused, please do tell me to slow down. As I said, I always appreciate when anyone here said, okay, can you please slow down? I want to understand certain things. Be aware of that when we start going into C. All right. Okay, so now that's kind of conclude the introductory part of this class on how to use things like Linux, how to use Git, how to use shell scripting. We'll move directly into the Q&A session for this class. Any question you want to ask me? One more thing I want to check with you. So after this semester, it's your summer break, right?
Yes.
So any of you might want to look into internship as a possible option. Please feel free to let me know. I know a few of my friends who are at a company basically, and if I can help, I will be more than happy to help you get connected to the right people who might be finding some basically some undergraduate student who are willing to develop some code, right? I want to tell you ahead earlier than later in the semester, because then there'll be more time for you to select what do you want to do for the summer. Or if you want to kind of like, okay, I want to maybe look into research, or like what does people do for undergraduate research, things like that. That is even more like something I can help even more, because it's basically what I do, right? And because the time today right now is Q&A. If you have questions about this class, even questions, so I've had a few students in other classes ask me like, how was my experience with internship at the company? Because I've been interning at Intel Labs, NVIDIA, AMD, and VMware, right? So they are curious about like, okay, when I go to this internship, what are their expectations? What do they ask me to do for the 3 months or the 2 months of my internship? And what do I get out of that, right? So if you have any of these questions, we have about 15 minutes. Anything related to the class, the content of the class, anything related to computer science in general, anything related to maybe your plan for the summer that you can basically something that I can help, right? Feel free to ask right now. I'll give the floor to you, right? So you can type in the questions, you can ask me directly, you can type in your into the private chat if you want to tell your friends who you are. Anyway, now is your turn. All right, I'll shut up. Sorry. I'll shut up and answer your questions. All right. Actually, before I shut up, one more thing. How is the pace of this class so far? Is it too fast? Is it too slow? Or is it the right amount? Okay. If any one of you think it's too slow or too fast, I'm a little bit concerned for people who think it's too fast. Okay. So I thank you. So basically, first of all, thank you for being honest, right? First of all, I want to make sure everyone can catch up. I would consider the pace of it. If anyone thinks it's too fast, I'll try to slow it down because I actually make it a little bit faster than the previous semester I teach this class. All this thing, all this content supposed to be fitting in 5 lectures. I did it in 4. Uh, if it's a little too fast, I assume that now that we have 50 minutes, so if I have the full, I guess total 8 hours, it should be good. Especially if I can see you face to face. That's actually always help. So I want to make sure I can improve going forward. Right. So now your turn. Any questions? If you don't have any question and you need to do something else or you need to attend other classes, feel free to leave the meeting right now and attend the class or whatever. Right? That's it for the content of today. The rest are Q&A. What's the workload like during internship? That's a great question, actually. So this is the information I gather from me and all my friends who actually went on for internship, right? So the goal, actually the main goal of the internship in most company, or at least the most competent tech company, like the good tech company, what they want is they want to figure out which intern is good so that they can hire them when they graduate. That's one of their main goals. Okay, for the possible field, that's another interesting question. So let me answer the first question. What's the workload like during the internship first before I address the second question? So the workload is basically this. They're expecting you to go in, work from 9 to 5, but the hour is not exact. Basically, you will be either you propose your own project and they'll call it internship project. It might be something fun for you to do. A lot of companies like Google or for example, when I was at Intel, right? Sometimes they hire students that, and then they come up with some projects for the intern, knowing the fact that these projects might not eventually pan out, but they want to see how you progress through problem solving. And if it does pan out, it can be good, right? I'll get to 7. Yeah. So basically, most company would assign project that would fit that they feel would fit in the allocated time, and then you would spend time working on a project. They would actually have a lot of activities for the interns so they can socialize, right? There'll be random like Friday afternoon that you get to hang out with all other interns. I have been to a soccer, like a football game. In one of the afternoon to basically they want to have like you mingle with other interns and other teams so that they get to know you and you get to know the team. The goal is to advertise the company to you as well because they believe that the interview process and the process to get you hired as an intern is the filtering enough already, so they want to kind of recruit you at the same time. Is first year student with hardly any CS knowledge also be okay? To be frank, it is. It depends on what team you go into and what level did you set the expectation, right? First of all, if you don't really, if you haven't really had a lot of experience with coding, right? One thing that you can help with, you can go and learn. They might not pay you that well, or they might not pay you, right? But they would give you like an experience that they feel like you can do. Sometimes they even teach you. So let me address the second question. What are the list of possible fields I can apply? I know the computer science and computer engineering company. So if I want to go deeper at things like computer system, hardware, software, which is development, right? You can kind of like tackle things like data mining, database, data analytics. Those those kind of work will actually sometimes it's surprisingly easy because it involves more of the math and less of the coding, right? So you would deal with Python code, trying to develop certain tasks that your mentor asks you to do. Yeah. So for hardware, I definitely recommend wait until at least like you get into computer architecture, which I eventually get to offer. Last this semester, I was planning to offer computer architecture. There's not enough people to sign up for the class. It turns out your previous lecture did wounding to all your upperclassmen, so they're all scared of hardware. It's not that hard. That way to make it easy. I hope I can do that. Yeah, I hope I can change. So there's no good computer architect in Thailand.
อาจารย์ครับ และอินเทอร์ชิพอันนี้มันจะเกี่ยวกับไอตัวอินเทอร์ชิพที่ต้องทำเอาเครดิตไหมครับ
I think it's doable to mix the two. Basically, the question is, does it, so let me rephrase your question. You have this internship credit, right, that you need to fulfill. Would the internship that I try to connect with my friends apply to this? Yeah, I think so. I think you can even like, so let's say you are not like right now you're first or second year, right? Let's say you're on a second to a third year or third year to fourth year summer, and you say, hey, maybe I want to go to a graduate degree, do a master or PhD, and then say, can you join, for example, my lab or Dr. Kanat's lab or some other professor's lab? I think I need to check, but at least in many other universities, that's also count as internship. So I think it's totally doable. We just need to check with the department, right? How long do we need for an internship? Most companies understand it depends on your summer schedule. That's the fact. It's everything the company understood. You need to go back to class. They are not gonna help you hostage. Like, hey, don't go to class. It is really, these things are typically much more catering toward your schedule. Yeah, okay, thank you. You get to teach architecture because you need that to graduate. Okay, glad to hear that. I would make sure this time I make the class easy to understand and hard enough that you get something out of the class. That might sound weird, but yeah, I've been planning this for a while. Before I got back to Thailand, I still think we are as a country incompetent in computer architecture in the whole world. From our country, I'm the only one who still publish research, and that's wrong. I need more people, so I will change that. That's my long-term goal, and I really want to get started with making sure the architecture class that I teach are the best they can. Because I've seen a lot of architecture class in Thailand, and they all suck. It's really bad. It's horrendous. Anyway, okay, any question in classes society 3? Content from previous, yes, it's a content from previous class. Don't copy the solution. Please do it from ground up. I think it's well thought out so that, and it's also easy enough that you can finish in, I don't know, like half an hour at most, right? It gives you all the exercise that you need to finish, and also one thing that will tell you straight ahead, right? The assignment that I'm going to give you, some of them will be content from previous classes. So I'll check your solution to some degree. Don't copy it from your upperclassmen solution or something. Please think through that, especially in this work from home online classes setup. the only the most effective way to learn is to still work on your own code and talk to your friends. I'm sure you have friends, so talk to your friends about how do I implement certain things in class. If you have questions, ask me, email me. I do reply to emails, and I try my best to get it back to you as soon as possible.
อาจารย์ครับไอ้ที่เขียนสคริปต์นี่ตอนส่งนี่คือ copy ที่เขียนในไฟล์ sh แล้วก็พิมพ์ลงไปเลย
So you can copy and put in a text box. You can submit the .sh file for the assignment. Both works. I think I'll make sure that you can submit the .sh file. But at the end of the day, as long as I see what you write, that's good enough. Okay? You are going to get, as I said, if you do the work and you submit it, even though it's right or wrong, you get full credit. These are for your own good. You need to do that exercise to kind of practice. The one that I'm gonna be grading seriously would be the assignment and the exam and all those things. In class exercise is exercise. I want to make sure you go through that and don't yes.
เวลาผม edit ใน terminal ใช่ไหม bi แล้วก็ sh file ถ้าเกิดผมพิมพ์ผิดมันมีวิธีลบไหมเพราะ backspace cannot delete it อะ
What do you mean?
เวลาผมพิมพ์
Yeah.
เกี่ยวกับ
Basically,
อะแล้วพิมพ์
yeah.
ผิด I don't know how to fix the typo so I need to like quit and like rewrite everything almost every
Okay,
time.
so instead of VI, I would suggest use Vim. Use this, and when you are in the editing mode, so Vim has the command and editing mode. Once you are in there, you can type in the letter A to go into the editing mode. That would behave like a notepad, basically. You type in things, you can do backspace, you can delete. That would work. And then to exit the editing mode, you do escape. Can you follow up with me by sending an email on how to, but basically I'll give you a cheat sheet on how to use Vim. Basically all the commands, that is not too long and useful. Is it? Okay, so that's a great question as well. So I'll keep this anonymous, but one of you asked like, okay, what if I don't do that well on your grade, right? This is what I interpret as like, don't feel like you don't do well at college. You might not get good grades. You can still do well at college and you can still fix it, right? Internship is actually one way to kind of like get over the burden of I didn't do well enough to get good grades, but I can show you I can work. You can do well on internships. You somehow might be surprised that some of the tasks that company asks you to do are actually easier. They need people to help them building something. But there's a caveat in everything, right? And what I need to still tell you is, one thing that a lot of companies try to seek is, if you run into problems, can you find way to reach the solution, right? Can you find a way to actually fix a problem, or at least be methodical about it, right? You might have to kind of revisit some of the material that you learned, how to build, for example, a linked list as a data structure, how to build a tree, how do I write code in C? Or if the company say, okay, can you write a Go language? You might need to go and kind of learn the Go language or Rust or Scala, a new language. That's another good question, and I don't like the way you phrase it. I don't believe that that's the word too dumb to understand some stuff. I think the correct word is you don't have the background to understand the stuff that they're trying to tell you. Basically, if I don't have certain background, what they would like to see from you is the improvement, right? Let's say the first day you got into the company, you were mind blown by the amount of information that was flown through you. And that happens. That happened to me too. Sometimes like, okay, what's going on? I need to slowly make sure I grasp everything, right? What they want to see is, did you actually try and improve on those lack of background so that you can basically you can tackle the problem. I think basically it takes like motivation and guts to kind of like bite through this problem. A lot of coding that you have to do nowadays. It more about, do you have background or previous experience? Because if you don't have one, then you can do exercise to kind of like go through those exercise and get the background, right? And I think right, at least for me, this apply for me for sure, right? I treat everyone that I teach as my students, even though they done with the class, right? If they have questions, I'm more than happy to discuss or give possible direction, or say maybe you want to look into this, look into that. And I'm sure at least with professor at Mahidol University at the CS department, you guys get one of the best group of teacher. That's one thing I can assure you. You guys get one of the best teacher you can possibly get in this country. So I'm sure they're willing to help you. Yeah. Like for example, I know Ajahn Kanat personally, and he's one of the smartest people on earth, and he is one of the most helpful professor on earth, right? So he's always also eager to kind of discuss things with your his student, and so there's no, ever said there's no such thing as too dumb to understand, but you, one thing that I want you to make sure that you need to do is, if you feel like you don't understand something, what are the background that you need to cover, and show them progress, right? They want to see progress. They want to see that, hey, if I actually hire this person, can they solve the problem? Because at the beginning, no one know how to solve the problem. That's why you need to develop a software to solve the problem. But can you troubleshoot, and can you reach the solution? I mean, hopefully that answer your question, right? Because a lot of you are still in the first year. I do understand this is the first time you actually do programming. A lot of people don't do programming in high school, and only a handful of people did programming in high school. So you feel the gradual ramp up of difficulty the first time you need to program, and you need to change the language that you program. And I think people understand that. Or at least if you feel like you try your best, you see the improvement, and the company doesn't really understand that, maybe the company might not be as good as they claim, or the team, right? Sometimes it depends on your manager, it depends on your mentor. So it's a personal skill involved as well. So I can't really say that, I guess.
I have questions.
Yeah.
Yesterday I tried the preparation part, like for in class like in class exercise, the third one, and I got like operation not permitted. And as I search, it say that I should like um allow the food is something, food is permission or something. So I don't know like what should I do, like yeah,
So
should I allow?
okay, so let's kind of like wrap this whole question together. Like when you see an error say operation not allowed, it means that you're trying to run that command, and yeah, sudo is one possible solution. But to actually figure out uh what do you need to do is uh the reason behind that error message, it means that something that in that command break the permission, break some of the requirement. For example, let's say you want to copy some content in your friend's folder that they set the permission, no one can write to my folder, right? With that example, specific to that example, they will say, I cannot write to that folder because your friend just said no one can write on it except me. That is
Oh,
what
I
it
see.
means by operation is not, there's a permission denied, basically, right? When you type in sudo, it means that I'm gonna elevate my permission into I'm a root, I'm a god, I can do whatever, right? So that is one possible solution. But when you type in sudo, please make sure you're aware of what you're doing, because if you do sudo rm-rf and a folder by accident, that is going to be leading to you crying in the corner in some instance. Right? So you want to avoid these kind of things.
I just like try to get the text file that you post like in the link.
Yeah.
But yeah, I just don't know like how can I like take that files into the directory that like yeah that you like you want.
Okay. One thing. Let me double check that in class exercise again, because it was from last semester, and it might be specific to the fact that you can go into the server. So give me by the end of today, if you don't mind. I'll fix that. Can you email me just so that I have the log of this, and I know there's something I have to do, because after this meeting I have like 5 more meetings until 6 o'clock, and I want to make sure I don't forget and do this. Sorry, do you mind? Whether you send me an email telling the exact problem with the files, and then I'll fix it.
Okay, but maybe I'm wrong because I just like confused it like yeah what should I do or something like that. So yeah.
Then just send me an email. I'll look into it after basically when I have a chance to check the email.
Okay, thank you so much.
Yeah, no problem. Okay, so that's another great question. So sometimes I think this hit many of you, right? Sometimes you compare yourself to your classmate and you feel you don't do well. What can you do to improve? One thing you need to understand is when you start your first year in college, you start at a different amount of background. Some people who have been programming for years, they have experience coding. So they basically can slip through some of these classes and still do well. And uh, and then what happened is you will feel worse because like you try your best and you still cannot produce the same output as fast as your friend. Right? I think it's a matter of the lack of background, and you can always catch up, right? So asking us question is one way to kind of like resolve that. And then one thing that you have to be aware is the fact that somehow you start from a different point, and I think for that person who asked me this question, I think you do okay. Like this is my honest opinion, but don't feel depressed. So if this is the direction you feel that okay, my classmate is doing way better than me, why do I even bother trying? Don't make it that way, because at the end of the day, I think you want to find certain job or task or problems that you are passionate about, that you feel that you're happy to keep working on this problem, right? Then that's basically what a lot of company is looking for. Can the problem that you're trying to solve match with the problem the company is trying to solve, and you are motivated to keep working on that, because at some point you will catch up. At some point you know the background material and you can start from there. And yeah, so I'm trying to cheer you up, but I think you are doing okay. If you're confused about certain topics, the best thing you can do, check back with us. I'm not None of us are perfect when we give lectures, right? And especially with the online format, it's so hard to tell whether you understand it or you lost it already. So I always glad that you ask me questions. I'm always glad that whenever I reply, it's clear your misunderstanding. And and I'm trying my best, kind of like make sure that you catch up to the topic. And I understand also that you have a lot of other classwork, so it takes time. It takes a lot of time management skill as well, and sometimes that can impact your grade, right? So don't feel like you're doing poorly. If you feel like you're doing poorly, then check back and see what background do I miss and how do I address it. Because at the end of the day, one thing that you might have heard about things like grade, I mean, grade matters, but it doesn't matter that much. It won't destroy you. You can always go work on a job. You might have to spend 1 or 2 years making sure you build enough resume that you can reach further, right? So that's a life goal. This is something I really want to kind of tell all my students that hey, grade is important for sure. It is important because it allows you to start at a better place when you start your job, right? But the process of how to learn and how to find the missing background information so that I can solve my problem, that's more important. Uh, if I need to take a PhD student, I rather take students who start with not as good grade, but I can see the improvement and can see the passion in actually like solving the problem rather than finding the best way to get the best grade possible. So hopefully you understand. Yeah. But one thing you need to make sure is you work hard. I think that's like one common thing that every single company wants to look at. Okay. Anyone else have any questions? Or otherwise, basically, I'll conclude the lecture. If you have any other questions, then you can feel free to send me an email. I'll reply as soon as possible. By tonight, I'll release the first set of assignment, and you have until 7 days from now, 17 days from now to finish it. The Monday midnight on the following 2 weeks. That's another great question. So one of your friends asked about thoughts on the website like Lead Code or Code War. Do companies care about the progress in them? I personally, I don't think they care about the progress in them, but they do care about the fact that you actually want to keep improving yourself. So those are great things. And I actually talk to my students that hey, so for those I have one master student who never have to program in any language other than Python. So I told him like you need to actually practice it, and actually told him to go to Code War and pick out the exercise in C++ so that he can actually work on a project for his master's thesis. So these are helpful tools that company is aware of. So it's always help. And at the end of the day, if you keep practicing, one thing that you can gain from it is during the interview, sometimes they ask you to code something. And these things can help in terms of like, okay, I've seen this before. I have seen some similar problem before. So at the end of the day, I think it's a useful tool, and it is free. Uh, and it's actually pretty nice compared to back in the day when I was undergraduate student. There's no such thing as this. The only thing I can do is basically keep working on the homework problem and kind of like go from there. So these days, there's a lot of tools online that you can take advantage of, and I encourage you to take advantage of it. If you have time, by the way, burning out is a big thing, right? So make sure I know if you want to study, it's great, but make sure you don't feel like you burn out when the semester begin again and you're like, okay, I have no energy left for this semester. Make sure you don't run into that situation.
Huh? I heard like for finding job, it's really useful if you have apprenticeship or something. So like,
Yeah, so I mean, basically, if you have previous internship like, what do you mean by apprenticeship? Is it like internship, or you work with some professor, or is it like is it like internship basically?
I think it's like a very long-term internship where like you work
Oh,
and
okay,
then they
okay, okay.
train you and stuff.
So would it help? It's a positive thing, right? So longer internship is a net positive versus shorter internship. But 2 months versus 3 months, if I own a company and I'm conducting the interview, I don't care. It's so close to each other. 2 months and 3 months doesn't matter. One thing that you can always do is when you go to internship, even though you know it's only 2 months, you can actually ask your mentor to see like, okay, one, I'm back in school. Are there open projects that I can still get involved and together they kind of develop after I'm back at MUIC, right? Uh, I'll give you an example. When I was a PhD student, I went to internship at VMware for 3 months, right? And then we are still working on a paper. So I basically take those, come back to CMU, and spend like a year working on it and publish 2 papers out of that internship. Uh, so that to me, that's kind of like apprenticeship that you talk about, right? And basically, uh, would it help? Yes, especially if you can at the end deliver some project that people can see and can explain what do you do in that project. So one of the interview question that I love to ask people, at least for me, is if they list multiple projects, I'll ask them, what do you do in that project? What do you do in that project? And have them explain. If you can explain it, it means that you are actually the one developing the code. If you can even explain the technical details, it's even better. Okay, so these are some of the interviewing tricks that you need to be prepared. It's better to be prepared. Let me rephrase that. It's better to be prepared before you go into the interview for actual jobs. Or at least that's my experience. I might be wrong. I got tied up with the Thai scholarship contract, so I don't actually have to find job. I have this slave contract for 20 years, so I'm not required to find jobs after PhD. The government forced me to come back here and work at TTGS. So yeah.
Wait, but like our summer is only 4 weeks long. Would that be enough to do anything?
So would that be enough to do anything? One thing that I would also possible option is you work with a professor that teach you, right? So instead of going to a company, ask them are there projects that they have that are ongoing that you can do it, that can allow you to put those items in the resume. Because some of these projects might be involved with certain companies. Some of these projects are involved in certain part of the research. Some of them are involved in like maybe developing a website for certain things, right? So these at least is flexible enough that after the 4 months you can kind of like still work on it if you want, or flexible enough like, okay, I hate this direction, I'm not gonna get involved in this area in computer science because I don't like it, and then kind of like, okay, I'm going to switch over to a different type of project. And working with professor, at least there's no risk involved in the sense that they tend to understand that students' interest, depending on it depends on the student interest in the sense that sometimes for me, I like hardware, I like system, right? I don't like front end. If you ask me to develop a website, I'll cry. But for many other people, I think most people, they'll rather develop a website and write scripts rather than writing back-end system code. They will cry in that case, right? So I think people understand that the 4 weeks is it's just be a little hard to get internship. One thing I recommend is talk to your upperclassmen and how they deal with all the situation. I'll take note of that. And whenever Bangkok open up again, whenever I actually get to go to Mahidol, like to teach at Salaya, like I'll drop by the lab and chat with your upperclassmen that I taught previous semester. Like, how did they deal with internship? Because I would like to be able to answer that question. Yeah.
อาจารย์ค่ะ I sent you an email already. So yeah.
Yeah, I still have all the PowerPoint open up, so I didn't check my email. I'll reply to you back as soon as possible. All right. It might be later this evening, depending on how my schedule look like for the meeting, but I'll try to get back to you as soon as possible.
No, just tell you to let you know the stuff.
Sure. Yeah. All right, cool. So I need to head into another meeting at noon. So if you have any additional questions, please feel free to send me an email. We'll meet on Monday. We have class on Monday. All right. There's class on Monday. I believe it's not a holiday that I need to reschedule the class. I think that's like some holiday classifiers I cannot teach on that day, but this one I think I can. So we'll meet on Monday. Then on Wednesday, there's no class. We'll meet on Friday. I'll send another poll on what time would work best for Friday slot for next week. Afterward, we'll resume the Monday, Wednesday schedule. All right. And I'm so sorry about the next week Wednesday class. I already, as I mentioned in the first week of class, I need to do an interview for my incoming students, and that's like a one day long event, and I need to make sure I have my slot open. Again, sorry about that. We will meet next week. We'll meet Monday and Friday. All right. That's it for the class. Thank you so much, everyone, for joining. Look forward to see you again on Monday, and then assignment will be out tonight. Okay.